Okay, well, welcome to part 2 of the Chapter 4 lecture notes for AP Chemistry. And what I'd like you guys to do is to have your PowerPoint notes handy if you'd like to make some notations on that. But in addition to that, you will be needing several pages. So make sure you've reached into your notebook and gotten pages 20, 21, 22, and 23, 24, 25, and then 26, 27. Your page numbers 28, 29, 30, and 31 are basically all the papers you're going to need. So to summarize, it seems to be pages 20 through 31, not all of which we're going to work with now, but which are good reference material or the worksheets that you're going to be assigned to do. Now, last year we learned 5 basic equations in chemistry. And yet in reality, all I gave you was the basics of chemical reactions. Pretty much most all of the reactions that we learned involved oxidation and reduction. Now, oxidation occurs when an atom or ion will lose an electron. And in the universe, if something's losing an electron, something else must be gaining that electron. And we call that reduction. Now, one cannot occur without the other, and I know the word reduction doesn't seem to make sense because it's picking up an electron. What's happening is when you gain a negative electron, your charge is being reduced. You're becoming more negative. Think of a number line might help. Now I'm going to reach over, so I may not be looking exactly at the screen here right now, but I'm going to use my cute little pen that I've learned how to use tonight. And I'm going to write a few things on there because what I need to do is show you how you can use a simple little mnemonic to remember it. And it's called oil rig. If you can remember oil rig, this is how you will start every oxidation and reduction problem all the way up to the very complex ones we're going to do in chapter 20. Here's where the mnemonic comes from. Oxidation is loss of electrons. O-I-L. Looks like I'm in second grade and learning how to print. And the second word, rig, I think you can figure it out. Reduction is gain of electrons. My pen seems like it's regressing. R-I-G. So that's how you can remember which is which. And every time you start a oxidation reduction problem, whether it's as simple as figuring out oxidation numbers like we're going to practice today, or something much higher level, you need to follow that mnemonic. Now, what we do to figure out who gained or who lost electrons, we assign oxidation numbers to each element, either in a neutral compound or some sort of charged particle. So really, what oxidation numbers are is they're kind of a way for you to use, oh good, I'm still black, an accounting method to keep track of what is being oxidized and what is being reduced. So it's kind of an accounting method to keep track of who's gaining and who's losing the electrons. So it's kind of like charges in a way, but kind of not. So there's a whole series of rules. Now I'm going to go through the rules, but I want to point out first of all, on page 20 is one version of the rules. And it has some examples on the back on page 21 that we will be working on. Page 22 and 23, it's just some sort of helpful information. I'm throwing that on the ground. Page 24 and also on page 25 is another set of the same rules. I kind of like the ones on page 25. It's straight out of your textbook. Use whichever ones work for you. But what I'd like to point out, and since I'm turning pages right now, don't worry about page 26 for the moment, but you'll see an answer sheet on page 27, which contains the answers for a practice worksheet that I will not be collecting. And that can be found on page 30 and 31. So as a self-test, before you take any quizzes or tests on oxidation and reduction, or redox reactions is another way to call it, you can practice 30 and 31 on your own and then use the key that is on page 27 to see if you know what you're talking about. We are going to be doing some practice problems together on page 21, but then I will actually be grading some on page 28 and on the back on page 29. So that will be your homework for the weekend. Page 28 and 29. Don't worry if some of these stump you and you feel lost. We'll go back over some of them, but you have to give it a shot. So elements in their elemental form are easy. Their oxidation numbers are 0. If you have a monatomic ion, like chloride or sodium, their oxidation number is the same as their charge. The only thing that's different, if I said, what's the charge of sodium? You'd say 1 plus. If I say, what's the oxidation number of sodium? You're going to say plus 1. And I was kind of stinky about that sometimes last year with my students. Now it matters. Nonmetals are typically negative oxidation numbers, although as you get into it, it's possible that in some compounds or ions they could be positive. Oxygen is almost always a -2 oxidation number, except once in a while you run across this stinky guy called the peroxide ion with a -1 oxidation number. Don't worry about that for now. When hydrogen is bonded to a metal, acting as a something hydride, it's a -1. If hydrogen is in the first spot and is bonded to a nonmetal, then it's a +1. So hydrogen's kind of iffy. Nonmetals are typically negative oxidation numbers. So fluorine, for example, is always -1. All of the halogens are -1. Again, it's possible in the more complicated oxyanions, negative ions that have oxygen, it can turn positive. Let's hold that thought. And the sum of the oxidation numbers in a neutral compound is always 0. The sum of the oxidation numbers in a polyatomic ion is the same as the charge on the ion. So that's kind of a lot of stuff. And what I'm going to ask you guys to do then is to switch gears with me to the other PowerPoint presentation. And I created this so that you could pick up on the practice worksheet found on page 21, maybe get a piece of scratch paper and work along with me as I try to get my little tablet pen working here. And I'll show you how to logic through simpler ones all the way up to more complex ones. So let's go to work on this. So my pen should still be black. Oh, it changed on me. I'll figure it out. Be patient with your old teacher. Now when I look at the problem on number 1, it has determined the oxidation number of each underlined element, and they underlined the sulfide. So what we want to know is how to use this side of the formula to figure out the oxidation number on the sulfide. Well, I go to my rules. I can see that in my rules, whichever sheet you want to use, the potassium is always a +1 oxidation number. However, there are 2 of them, so you have to multiply it by the number of the atoms or ions that are in that formula. And I get so far a total of +2. In a compound with no charge written in the upper right, the sum of all the oxidation numbers has to equal 0. So by default, my sulfide must be -2. Because a +2 plus a -2 equals 0. So that's about as simple as a kind of one that you can work with. Let's do a few more. Question number 2 has NaClO4. Let me go back. Let me make sure that my pen is talking correctly to all of the rest of us. Black pen, here we go. As I look at the formula NaClO4, Cl is underlined. So now I could start with either side, the 4 oxygens or the sodium. So let's go over here and say the sodium, according to the rules, its oxidation number is the same as its ion charge. That's a +1. Now on oxygen, unless it's a peroxide, but this one isn't, oxygen is always a -2. But I have 4 of them. So for the oxygens, I go 4 times a -2 equals -8. And now I have to do kind of an interim total. So far, +1 added to a -8 is -7. All the sum of all the charges in here must equal our oxidation numbers. Let's be correct. All the sum of the oxidation numbers must equal 0. There's only one chloride, so it has to have an oxidation number of +7, because that's the only way a -7 added to a +7 can equal 0 on a neutral compound. Moving along. Let's go to our BrCl. I have to be honest with you guys, I don't even know what that compound is. Bromium chloride? This one's simple. They have underlined the bromine. All of the halogens are -1, so that one's an easy one. The bromine has to be a +1 because the 2 added together must equal 0. We like them like that. Number 4 is Li2CO3. Got a little typo here, that should be a capital O. They've underlined the carbon. Let me go back. Let me pick up my pen. And they've underlined the carbon. So starting with the lithium, which is in a +1 ion, it's a 1+ ion. Its oxidation number is +1. 2 times a +1 equals -2, +2. Oxygens are always -2, but I have 3 this time. 3 times a -2 equals a -6. +2 added to a -6. Right now I'm up to a -4 on the charges coming from the oxidation numbers coming from the lithium and the oxygen. So therefore, since there's only one carbon, it must have an oxidation number of a +4 because they all have to add up to 0. I think I have one more before I jump up to some more difficult ones, and that's number 5, OF2. They've underlined the oxygen here. You'd think I would learn. So they've underlined the oxygen as the one that needs to have its oxidation number. Fluorine is always a -1. I have 2 fluorines, each one with an oxidation number of -1. So the amount of oxidation number so far from just the fluorines is a -2. So the only number that the oxidation state of oxygen can be has to be a +2. Now I hope that these have been fairly clear-cut examples. We have a few challenge ones to show you and a few subtleties of technique. So I think hopefully you've gotten kind of the feel for how these things run. So I'm jumping up to problem number 9 now. And on number 9 it's a little bit more difficult only because it's a more complicated looking formula. Don't let that stress you out. Underline the boron. That's the one this question wants to know, what is the oxidation number of it. So as I work this out, I have a magnesium, which is a +2 oxidation number. It's in Roman numeral column 2. Its charge is 2+. Its oxidation number is +2. Now the thing you got to remember about this guy is there's a 2 outside the parentheses and you have 4 fluorines inside. So for the fluorines, I got to do a little bit of math. I have 4 times 2 equals 8 of those guys. And now each one of them, if you look at the rules, it says fluorine's always going to be -1. So there's -8 worth of oxidation numbers coming from the fluorine. If I add a +2 to a -8, so far my running total is an oxidation number of a -6. Well, we learned that you have to have all the charges add up to 0. So you're thinking, okay, I got to add a +6. But wait, this 2 outside the parentheses also applies to the boron. So a -6 plus a +6, now you have to ask yourself the question, what number times 2 equals a +6? And the answer is +3. So when they ask for an oxidation number, they mean for one boron. 2 borons, if we assume I got the right math, is 2 times a +3 or a +6. And that added to the -6 of the other 2 elements in that formula, that will get me to the right answer. The oxidation number of boron in this one is +3. I'm going to do one more. So if you would jump down to number 13, and as you can see on number 13, now we have a polyatomic ion. This time they've identified they want the oxidation number on the niobium. And keep track this time, the sum of all my oxidation numbers isn't going to be 0, it's going to be 3-. So I go to my rules. Oxygen is a -2. I have 6 fluorines, so I'm going to go 6 times a -1 equals -6. So far, I have a -8 sum of oxidation numbers. So now I have to ask myself, I'm not adding up to 0 now, what number added to -8 equals -3? And the answer, of course, is +5. Okay, I think that's a pretty good introduction for now. So what I'd like for you to do is to complete any of the exercise 3-1 practice problems on page 21 that I haven't done, and I will give a key to Miss Laffey. And then if you feel like you would like to start working on your homework, if you have time, I think I would start with page 29 first. That would be my focus. And then you can come back and work on page 28. And so that's a good introduction to oxidation numbers. Again, it's an accounting method, as we'll see as this gets more complex, of keeping track who gained and lost electrons. But the skill that you've just learned is the pre-kindergarten skill that you need to be able to do much more complex problems. So for now, learn the process, and we will learn the application of this later. Okay, see you at the next vodcast. Take care.